Okay, this is the problem that you're given right here. Lynn has a cube, and at each side of the cube, she writes a different positive. I think they should really say integer here, or whole number other than 0. The numbers on opposite sides of her cube are consecutive, which means like it could be 5 and 6, 9 and 10, 50 and 51, doesn't matter. So think of the pairs of faces as top and bottom of the cube, left, right side, right side, and front and back of the cube. So if we put the number 5 on the top, then 6 would be on the bottom. We put 12 on the left, 13 would be on the right, 10 on the front, 11 would be on the back. And the sum of all those numbers is 57. Similarly, well, second row, you can follow along. But now here's the general example. If x sub 1 is the number on the top, then one more than that is x sub 1 plus 1, x sub 2 on the left, x sub 2 plus 1 on the right, x sub 3 on the front, x sub 3 plus 1 on the back. And if we add all those up, you can see that there's 2x sub 1s, 2x sub 2s, 2x sub 3s, and then we're adding a 1, a 1, and a 1. So here's an expression for the sum, assuming x sub 1, x sub 2, and x sub 3 are positive integers. And if we set that expression equal to the sum and solve for x sub 1 plus x sub 2 plus x sub 3, that'll give us an idea of what those integers have to look like. So I subtracted 3 and divided by 2. This is an expression for x sub 1 plus x sub 2 plus x sub 3 in terms of s. If you subtract 3 from s and then divide by 2, that's what these three integers have to add up to. So for example, over here, for 57, I subtracted 3 from the sum, divided by 2, got 27. 5 plus 12 plus 10 adds up to 27. And 1, 3, 5 gave us 21 minus 3 is 18. 18 divided by 2 is 9. 1 plus 3 plus 5 is 9. Okay, so now we'll try each of these in turn. If I use 36 for the sum, 36 minus 3 is 33 divided by 2. This is not an integer. So 36 cannot be the sum, assuming we're putting integers on the faces of the cube. B looks like it works. 31 minus 3 is 18. 28. 28 divided by 2 is 14. So for example, if you have integers 2, 5, and 7, that adds up to 14. So the opposite faces would have 3, 6, and 8. You add all those up, you get 31. So it looks like 31 is a possibility. Same idea for C as for A. You subtract 3 and divide by 2, you do not get an integer, so it can't be C. But for D, 19, the sum minus 3 is 16 divided by 2 is 8. Here's some integers that add up to 8. Here's the numbers on the opposite faces. One more. Those add up to 19. So it looks to me like the answers are either D or B. There you go. Hope that helps. If you have any questions, post a comment.